let's take a look at these square problems. We've got square QRST with half of a diagonal length of 5. So let's add what we can. We've got 90-degree angles here. The diagonals are congruent to each other. Remember, the diagonals are also perpendicular to each other. It takes that from a rhombus, takes that property from a rhombus, and all the sides are congruent to each other. So we've got all this going on with my square. Okay? Now, we're trying to find the perimeter of this entire square, which means we need to find one of these side lengths. But how can we find this side length if we've only got half a diagonal? Well, there's a couple different ways. We could recognize that inside my square are 4 isosceles triangles. So this is going to be 5, 5, and 5. Each of those parts is going to be 5. Okay? Now, if you remember also from a rhombus, it's taking the property that the diagonals bisect the angles. So each of these is 45 degrees. So that means we've got another old favorite, a 45, 45, 90 triangle, where the side length is 5. Now, the hypotenuse, that's the side length of the triangle here. Okay? So we've got a 45, 45, 90 triangle here. Here, let me rotate it just so it kind of looks similar to where I took it from the triangle, or from the square. Okay? So if you remember in our 45, 45, 90 triangle, you got x, x, x squared roots of 2. Now, this 5 that's given to us is opposite of 45. So that's playing the role of your x. So that means this is going to be 5, and this is going to be 5 square roots of 2. So QT is going to be 5 square roots of 2, which means every side length in this square is going to be 5 square roots of 2. So to find the perimeter, we're just going to take 4 times 5 square roots of 2, which is 20 square roots of 2, which is approximately, if I use my calculator, 28.284 units. So here is the exact perimeter, 20 square roots of 2, and the approximate, 28.284. Okay, so that's how we can tackle that one. The next one is saying QRT. QRT, let's identify where that angle is located. QRT is talking about this one up here. Okay, that's a 45-degree angle because it's half of 90. That 90's been cut in half. So 45 equals 4x minus 25. So we just have a simple two-step equation here. Add 25 to both sides. We're going to get 70 equals 4x. Divide both sides by 4. And x will equal 17.5. Okay, so those are the square problems. Let's hop over and finish these rhombus problems. So in the first one, we've got, let's add what we can. We got 4 congruent sides. We see that 90 degrees there in the middle where the diagonals bisect each other. If you remember, the diagonals also bisect opposite angles. So if this angle is 21, that means y also has to be 21 degrees, which means up here, both of these parts also have to be 21. Okay? Now, we could now set up a right triangle here. We got a 90 degrees there, 21 here. We're trying to figure out what x is. So we just got triangle sum theorem. 180 minus 90 minus 21, x, so 180 minus 90 minus 21, that's what x is going to equal. That's going to give me 69. So x is going to equal 69 degrees there. Okay? We could have also put 69 down here with alternate interior angles, or recognize that these angles are cut in half. Okay, so we can fill in the rest of my figure there. I can even put 21 in here for the y value, okay? So in the next one, we want to find GT. Find GT, so that's this whole thing here, okay? If GR is 4a minus 5 and MG is 9a minus 20. Well, right off the bat, I know I'm dealing with side lengths here, the GR and the GM. All the side lengths are congruent to each other in a rhombus. So I'm just going to start by setting these equal to each other. Okay? So that's going to be 5a equals 15. So a is going to equal 3. So I'm going to plug that a back in. That's going to make this, every side length, 7. So I am trying to find the entire diagonal there, okay? We could set up law of sines. We could set up a law of sines to find all of GT. But what I'm going to set up is trig, to kind of review that, in order to find half the diagonal. Because remember, there's a 90-degree angle right here. Okay, we're going to review trig here because if I can find half the diagonal, then I just need to double that to find the whole diagonal. Okay, so that right triangle, let me zoom out here. This top angle is 69, this one's 21, and the hypotenuse is 7. Now the side length I need is this side length right here. Okay, that's the side length I need. So I'm going to use the 21. X is opposite that 21, and the 7 is the hypotenuse to that 21. So that's telling me I'm going to use sine. Sine of 21 is equal to x over 7. If I multiply both sides by 7 and plug into my calculator, I see that x is approximately 2.508 blah, 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 blah. So in order to find the entire diagonal, I'm going to multiply by 2, and GT, looks like a 6, GT will equal 5.017 units, okay? So that's how we can use trig with our right triangles in order to find missing side lengths. Some tough problems here, not just with the rhombus, but rectangle, square, rhombus. You see, it's using a lot of previous knowledge in order to tackle these problems, in order to solve for these missing angles or missing side lengths. So make sure you practice. If you have any questions, talk about it when I get back. All right, have a good one.